Alright guys, today we're working on a 2009 Chevrolet Cobalt LS 4-door sedan, check engine light, traction light, and we've got engine power reduced message on the DIC, cycling around with service traction. So 9 times out of 10 this is indicative of some type of a wiring harness problem, but let's go ahead and pull the codes, see what we get, and see what this problem specifically is so we can repair it. Alright, while we've got this error happening, we're just leaving the engine running with this problem. We're going to fire up our Tech 2 scan tool, and we're going to see what the codes are for this. Powertrain 2.2 automatic, ECM DTCs. Okay, communication is fine. Let's see if we have any DTCs. We have one. Let's see what it is. P0641 5-volt reference circuit. Yep, so somewhere we've got a short in the 5-volt reference 1 circuit. Now, let's see if we have any other codes. Pop into the TCM. No codes on the TCM. Just going to check a couple other modules. Let's go back, check the body control module. She's chattering away here. Okay, so there's a bunch of different modules here, but the only one we're really interested in is the BCM. See if there's any codes on the BCM with this situation. Okay, we can talk to the BCM. Status 0 means there are no codes. Alright, last thing we're going to pop out, went too far. Going to chassis. Without RPOGL4 on this vehicle, so we got a power steering module and we got an ABS module. Let's check the ABS module. Usually these shorts will cause something else. There we go. C0561. Invalid serial data received. So this is just a diagnostic code. It's just telling you that there was a bad message on the bus that the brake control module saw, but it's not the brake control module. Right? It's just letting you know it's not me. So that comes in a pair with this particular problem. C0561 and P0641, I believe, is what our other one was. Alright, so while we've got this going, let's see if we can get any data. Unfortunately, I am not seeing anything useful here for what we want. Right, so reduced engine power active. That's useful to know. There we go. 5-volt reference 1 and reference 2 are both showing 5 volts. It's occasionally fluttering up to 5.1. It's telling us the 5-volt reference 1 circuit is okay. Yet we're still in this mode. Alright, so this is the data I was looking for. See if there's anything else useful here. Not really. Alright, so we got the data we're looking for, but it's not really taking us anywhere because currently the problem is not manifesting. So we're currently where we're supposed to be on the 5-volt reference, and currently the code is not going to be set because the circuit is currently okay. Alright, so we're not currently exhibiting the problem, so this isn't going to help. What I was going to try and do is going to come down here, and I was expecting the live data to show that this was not okay, and we could go around and try to hunt for the short until it flipped okay, and then we would have some hint as what's going on. Let's pop out and go back to the DTC and see what the snapshot data showed at the time it recorded the code, because right now everything's fine, even though it's still exhibiting this problem. This code's going to clear, I think, on 4 restarts, with it not currently happening. Alright guys, I noticed right before I switched out of the screen that it is jumping to fault. We just got to wait long enough. So we are getting this condition detected in the scan tool. So that's good, because that means now we should be able to isolate the problem in the wiring harness using the scan tool with this particular setting to tell us when we get the fault. So right now, this, every time it goes to fault, the wire is getting either, I'm going to guess, shorted to ground. Is what's going to happen if we'll take a look at the service manual. This code, there's 2 codes for this. I think one is short to ground, the other one is short to voltage. If you short to ground, the engine control module is going to try to drive more current and raise the voltage. And when it detects it's having to do that, it's going to throw the code because it's a short to ground. If it shorts to voltage, the current's going to get drawn up because of that, and the ECM is going to set a code because of that condition. That's much less common to have. This is most likely a short to ground. Every time it says fault, that's when it's happening, as the engine's sitting there wobbling. So we're going to jump into just popping the hood and seeing what we see. Alright, let's take a look at the service manual, either the hard copy or the online one. We're going to look at the hard copy one for the 2009 A car. Let's cover the Cobalt from Chevrolet as well as the Pontiac G5. We're in volume 2. We go to the actual DTC 0641, which is the actionable code that we have here. 41 is for reference 1, 51 is for reference 2. Very easy to see what the causes are. So they've got this short to ground, or an open, or high resistance, short to voltage. And they give you where the codes land. So all we have to look at is 0641, and it's either going to be a short to ground or short to voltage. And we can see it can be the accelerator pedal position sensor, the air conditioning refrigerant pressure sensor. It can be the exhaust camshaft position sensor, the fuel tank pressure sensor, the intake camshaft position sensor, the manifold absolute pressure sensor. So those are the culprits. 1, 2, 3, 4, 5, 6. I would give you a 7th one, the wiring in between all of them, because these are all on a common bus. A couple other things before we jump over to the schematic. The conditions to set the DTC. The ECM detects the voltage out of range for more than half a second. Clearing it is a type A DTC. It means it's going to clear automatically by itself after 4 successful engine cranks, where the engine starts successfully and the condition doesn't exist. It's going to automatically clear. What other things in here are helpful to know? The schematic we're going to take a look at on page 9303 in just a moment. Let's see if there's anything else on here of use. Not really, because they're going to walk you through checking all of these different sensors, looking to see if you've got a short. So if we go back over here, here's the schematic for the 5-volt reference. This is 5-volt reference 1. This is 5-volt reference 2. We follow through what we've got coming out. This big box here is the engine control module and the particular wires that are driving. Here we have the AC sensor, camshaft position sensor. This is on the exhaust. Here's the intake, fuel tank pressure sensor, and manifold absolute pressure sensor. So there's our 1, 2, 3, 4, 5. I thought I counted 6 before. Maybe I missed one here. They're not showing it in this scene. 1, 2, 3, 4, 5. Go back and see what we're missing here. But anyway, that's the schematic. And then this is just another view of the engine control module, just showing the different lines and connections. So the standard protocol to debugging this is to go to each of these sensors and unplug it one at a time to try and see, is it short here, 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 right? We're going to skip the fuel tank pressure sensor because that's really, it's in the back, it's in a totally different area, and it just doesn't fit the symptoms. We'll do that guy last. So we'll start with AC. That's easy to access on the compressor. Then we'll take a look at these other ones. So let's pop the hood, get it up on ramps, and start debugging. Let's come back here a second. I actually, as I was closing the book, I saw our last module, right? So on 5-volt reference 1, there's this line here that hops over all these others and runs down to the accelerator pedal position sensor. That was the other one that I was hunting for earlier. So there's our last one. So 6 sensors and then the wiring in between them. All right, what about that second code, DTC C0561? When you have these wiring short problems, you'll probably have this code as well, although you'll need a high-end scan tool like the Tech 2 to see it. Just these regular OBD2 readers aren't going to catch these ABS codes. This is just a complaint that the message across the communication bus was invalid or corrupted. And the only thing this tool is here for, right, it says that it sets this DTC if the electronic brake control module detects an invalid serial data message when communicating with the engine control module and the body control module during a traction control or stability control event. That event, and the reason you saw that on the DIC, when this short happens and it says traction service is part of what this error is caused when you have that short, it's going to end up disabling the vehicle stability enhancement system or the traction control system. And then it's going to turn on the indicator that the traction control or stability control has been disabled. It gets cleared when the DTC is no longer present automatically by the EBCM. So you don't have to do anything. If you fix this problem, it'll go away in 100 cycles, 100 drive cycles when you start up taking the thing for a drive. All this is an aid to the technician. It indicates there's no problem in the anti-lock braking system, there's no problem in the traction control system, and there's no problem in the vehicle stability enhancement system. ECM, the BCM should be checked for the possible fault. So we're going to do all of our debugging on the P0641 code, and we're going to ignore this one. All right, guys, this is where we're at, right? So we noticed, we first were trying to see what we could action on these sensors, like, moving the accelerator pedal for the throttle, for the accelerator position sensor, and kicking the AC on and off for the AC. Now you notice we're on this fault here, and it's been sitting just fine. And now I'm going to come over here, and I'm going to turn the AC on. And as soon as I turn the AC on, we start to get the fault. And it's intermittent, but if you watch it, you see it flashes default periodically. And if we turn the AC off, it doesn't fault. So that's an incredible, helpful clue to narrowing down having to check all 7 of those possible sources, right? All 6 of those sensors and the common wiring. What we're going to do is we're going to just go straight for the air conditioning sensor and the harness going to that. And we're going to check for external damage to see if maybe it's a problem with the harness. Then we're going to check the actual sensor. All right, this sensor here is not on our reference 1 circuit for this model year, but we can see that this harness here has rubbed through. Just constantly sitting going like this all the time. But when we open it up, there's no damage on the wiring yet, but we're going to repair this to reinforce it just in case it becomes a problem in the future. But this is what you're looking for as you check each of those sensors I mentioned. You're checking for, is there fraying damage where the connector itself is plugging into the sensor that's near anything metallic, or anywhere along the harness going into the sensor where it's coming into contact with something metallic. Remember, the engine itself as well as the car body is the ground. So wherever the wire might have an opportunity to touch anything metal is suspect. So you want to follow these kind of harnesses. Similarly, going down below to the air compressor for the air conditioning, and also the sensor related to that, you're going to check all the wiring looking for where it might be rubbing. All right, just showing you the final part of this proactive repair. We're putting a piece of 3M Temflex 1700 vinyl tape, and we've cut a new piece of wire loom and put it around the original wire loom. Just run this really tight, stretching it even. All right, so what that's going to do is that's going to give us 2 things. One, it's an extra set of insulation, and the other thing is because it's new and sticky, and still has some rigidity to it, it's pulling it away. If you take a look here, it's going to keep it raised up away from this, right? So it may have a tendency to bounce up and down periodically, but it's not going to be sitting there going like this. So this will last a while. All right, guys, so the air conditioning sensor turned out to be a dead end, but we did find something related. So the air conditioning sensor was a clue. When the compressor was on, we were getting enough vibration to uncover this particular problem. And so with that, we zeroed in on this camshaft position intake sensor. And what we can see here is this wiring harness was sitting pinched behind this bracket. And if we zoom in here, hopefully you guys can see this. this blue wire has a nick in it. So if you zoom in there, you can see that nick, and you can see the silver of the wire. Right there. So we think this is the cause of this particular problem. But how do we test that? How do we verify that? Well, the way I'm going to verify that is I'm going to take a test light, hook it up to a good ground. We're going to verify we got a good ground because the test light lights when we hook it up to this positive terminal right here. And what we're going to use that is we're going to use that to touch the ground. And then what I'm going to also do is I'm going to bring this oscilloscope over here and I'm going to hook it up to the 5-volt reference. So to do that, I'm going to disconnect this harness from the sensor, and then we're going to touch that ground line around that damaged area of the wire, and we're going to see if that pulls down our voltage, and if it does, that's at least one of the sources. It doesn't mean this is the only place, but this is definitely one repair we need to do. All right, guys, to get this sensor off, there's this little gray kind of safety clip that we have to get out with either a pick or a small flathead like you see me doing here. Just kind of push that down while you pull it. I'm going to have to block your view for a little bit here. This guy's really been on there for a long time. It's probably the first time this has been off since it was assembled in 2009. All right. And if that's off, we can then remove the actual connector by just giving it a pinch like that. So we're just going to take a moment to get any crud and stuff off the actual sensor connection. And then we'll clean up the outside of the socket, and then we'll hook up our scope. Alright, so our camshaft position sensor on the intake side is our suspected culprit. The dark blue line here on the 5300 circuit coming from pin 33 of the engine control module, coming into pin A of the connector on that sensor. That's the 5-volt 1 reference. B on the 5301 circuit is the low side on the tan wire going to pin 20 of the engine control module. So remember, this schematic that I'm showing you here is both the 5-volt and the low reference buses. If we take a look at another section of the service manual, we can see here's the actual connector that we're going to pull off of this, right? And there's A, B, and C, and the two ones that we were interested in is A, which is the 5-volt reference, and B, which is the low reference. And they actually tell you that down here, right? So they tell you that depending on where this connector is found, because it can be used on two different types of engines, dark blue on ours, circuit 5300, is the 5-volt reference LAP, and then there's also a gray, GY would be a gray on circuit 705. It's used for reference 2. And that's the L and F reference. And then, of course, the tan, two different circuits, 5301 and 552 is going to be the low. And then on all of them, the orange, the OG, would have been the cam sensor signal itself. All right, guys, we've got the key just turned to the lamp test position, the ignition key. You can see our meter, we're reading 5 volts exactly on our reference voltage. And then we've got our oscilloscope probed into the back of the connector that goes into the sensor. And all I'm going to do is I'm going to take this test lamp and I'm going to run it over that damaged area of that dark blue wire. If you watch right here, we should see this glitch out. See that? That little glitch right there? What's happening in that little glitch area, very intermittently, and the magnet of our light just grabbed this. Very intermittently, because we caught this pretty early. This is just a tiny piece, as you saw right there. There's just a tiny piece of the wiring that's exposed. And it's rubbing right along the edge of this bracket where the paint's also been worn off. So this is our culprit. We've now been able to verify both from the circuit diagram of the circuit that's involved here for this sensor, as well as recreate the behavior. I'm sure we've thrown the code a couple more times as well. So let's go ahead and repair this now. All right, for this kind of repair, since it's so relatively new in our discovery of this damage, I'm not going to cut the wire. What I'm going to do is I'm going to clean it up chemically. So So I'm going to start with some 50% isopropyl alcohol. I know this is 50% water, guys, but what we want to do is get the surrounding area. We're going to try and keep it off the actual damaged wire. We're just trying to get it on the insulation, right? So we're not rubbing it into the copper. That's just to try and get some dirt off of it. Then we're going to hit the exposed wiring with some deoxit gold G5, because we want to get anything that went in there out. This is not an area that's exposed to the elements, being way up here on top of the engine. If this was something below, I'd elect to cut this section out because moisture could have already gotten in there. But where we're at, that is not a concern. All right, so with this all cleaned up now, you can really see a really good view of this. And again, if we zoom in there, you can see that neck and you can see the silver. Just a tiny, tiny bit of the metal is protruding through. And so what I'm going to do to seal this up is I'm going to use some GB Gardner Bender liquid tape. It's basically just going to repair the insulation as the first step. This is not the only thing we're going to do. It's just the first step. We're going to be very liberal with this. We're going to let that set up. Now, originally, all they did on the factory was they had it wrapped in vinyl tape. Well, we're going to rewrap it with some 3M Temflex 1700 tape, top grade stuff. But then we cut a little piece of wire loom just in case this guy migrates back over, and we're also going to get that in there as well. So that should take care of this problem. So let's just let this set up, and then we'll come back and finish up the last part of this repair. All right, so our liquid tape is dry, and now we're just going to restore the original factory covering, although probably at a little bit higher quality. For this, we just want to find the original tape tears, and we'll wrap this around accordingly. Tightly. Then we'll take our loom section that we've cut, work this harness into that, and then we'll secure that with the same material at both ends. And that will complete this particular repair, because we can't be sure that over time this won't work back into the same vulnerable spot. And it's going to be one of those kind of things where you just have to coax the driver of the vehicle to give it a check whenever they're in here doing an oil change or something. Can't really relocate this particular harness. It's not enough distance to do that. All right, then we'll get this guy back down and reconnect him. And we'll try to keep him up. What happened is he wedged himself in like that. So we'll try to encourage him to stay above this. What happens is as the engine moves, right, it just saws through this. It might take 10 years, it might take 12, but eventually it'll saw through the plastic. We're going to put our retaining clip back on our connector. And that completes this repair. So I hope this helps you out with this particular one. We showed you some of the other places that you could check besides this before we got this far. If you found this video useful and it helped save you some money to get this repair done yourself, go ahead and hit that like button and pay it forward. I really appreciate it. And as always, thanks for watching.